Okay, so this is just going to be a quick little tutorial and a bit of a recapture of solving systems of equations, linear equations, using elimination. So elimination rules are basically this in a nutshell. Your A's must be the same, your B's must be the same. So one or the other must have the case. So once we have their A's the same or we have B's that are the same, this will allow us to add or subtract the two linear equations. Now, what do I mean by A's and B's? So generally speaking, when you do this formula, okay, you're going to have something in the form of, okay, standard form, which means you're going to have A, okay, X, so AX, all right, plus, and then you'll get some B, okay, B, y, and then that's all going to be equivalent to some value of c. So the c is arbitrary in this. We won't be using it. It just comes along for the ride. But what you need to have is both equations will both be in standard form. If they're not both in standard form, then you shouldn't do the elimination method until both of them are in the same form. It doesn't necessarily need to be in standard form, but it's the most common and it's the easiest one to work from. So I always suggest to my students just to turn it into standard form if it's not currently in standard form. So little recap of this, okay? Your A's must be the same. So that means your coefficient of X, all right, your coefficient of X must be the same, or your coefficients of Y must be the same. And now, I don't care about sign at this point. I'm just looking at the number, all right? It could be positive or negative. That doesn't matter, but I am looking specifically at the value of that number. And if they're the same, then that's awesome because it allows you to add or subtract right off the get-go. If they're not the same, then we have to do something. And we're going to run through these two options pretty quickly and in the most basic way to get the problem done so that you understand what's going on. All right, so let's get to it. All right, so this first problem, we're just observing the coefficients of X and the coefficients of Y. So basically the numbers in front of X and the number in front of Y, and we're asking ourselves, are they the same? And if not, okay, then we need to convert them. But in this particular problem, what I'm going to note out here is that when I look at the X's, there is a 10 in front of both X's. Now, I don't care that this one's negative and this one is positive. The only thing that negative and positive is going to allow to dictate what I do is the way that I combine line 1 with line 2. Am I going to add line 1 to line 2, or am I going to subtract line 2 from line 1? And in this case, okay, the goal is to make 0. Make no mistake, it's called elimination because you are trying to eliminate a variable, which means you're trying to turn one of the coefficients into 0, so I no longer have that variable in the problem. So in this case, you are going to take the 10 and the negative 10, all right, and you would add them because think about it if you subtracted them. So what is 10 minus negative 10? And if you want to, just do both. And if you have a calculator present, just use the calculator and it will give you a 0 if you're really just not good with doing the mental math of this part. So 10 minus negative 10 is actually positive 20. So that doesn't do elimination. Elimination is to make something go away, which means to turn it into 0. So in this case, I have to add. Now, I am a fan of just putting an addition symbol in between all of my stuff. So this is 10, okay, plus negative 10. And then I will go in between my y's. I will put plus, okay, and then between my c's, I will put a plus. Most of the time, if you're not doing that, right, because now I'm just thinking about going vertically here, okay? So I'm simply cutting this down into two pieces. So 10 plus negative 10 is 0. I can cross them out, but I am going to, just so you know, I do like to, just for me, put a little 0 at the top just to remind myself, okay? So anyhow, now I do positive 5, okay, positive 5 plus negative 9, and positive 5 plus negative 9 becomes negative 4y. Okay, so I have one variable in the problem, then I go over here, equals, so these equals both drop down, right? So boom, equals. And then I have negative 25 plus negative 11, which is just negative 36. And the beauty about the elimination problem when they're set up like this right off the get-go is they literally go directly into a one-step problem that you learn when you're first a kid, and then all you got to do is divide. So here we go. We divide by negative 4, divide by negative 4, and what I'm left with is that y equals 9, okay? And now once I have y equals 9, I'm not done, all right? So what I need to do is I need to find the x, because this original equation had x's and y's in it. So since I combine them for x's and y's, what I'm going to now need to do is I am going to need to plug that y into one of those equations. So here we go. Just pick one of those equations from the get-go, and I'm just going to choose the top one. So 10 times x plus 5 times y equals negative 25. And wherever I see a y, I'm just going to throw a 9 in its place. So this becomes 10 times x plus 5 times 9 is now equivalent to negative 25. And now I'm going to solve this equation in a second here. But first I'm going to clean this up because we know that 10x plus 5 times 9 is 45. Is that equal to negative 25? Okay. So moving on from here, nope, that's right, okay. So moving on from here, okay, what I'm going to do is that I'm going to go ahead and I'm just going to simplify and solve this, okay? So here we go. So what I'm going to do is two-step equation, so minus 45. So I'm using, okay, I'm adding opposites here, right? So to make 0, all right? And then I get that this is 10. X is now equivalent to negative 25 minus 45 is negative 70. Divide by 10, and I will get that x is equivalent to negative 7. Now, most teachers are happy with that. That's fine. I just want to reiterate very quickly that what you are solving for is an intersection point of line 1 with line 2. So what you just found is the coordinate point of negative 7, 9, in which those two lines intersect. So you found an intersection point. All right, on to the next one. So now, the next one. This one, when we take a look at it, okay, look at the x's. Oh, wait, 2 and 7, not the same. I look at the y's. Hey, 6 and 4. Again, I don't care positive or negatives. Ooh, 6 and 4. That's not cool, okay? Neither of them are the same. So if you're just looking for a quick method and you don't care what the numbers are that you create, here's what I'm going to tell you to do. It is the easiest thing on the planet Earth to do, and most teachers don't even teach this way. In fact, I didn't even teach it this way in my class, and I'm thinking that I probably should have because it's a lot easier to think about. A lot of teachers will go through and say, oh, you got to find the LCM. That's the most technically correct way of doing it, but we're just trying to get this problem solved for, and there's no rule that says I have to do it any particular way. So I'm just going to give you a quick little way that makes this very, very quick and easy for you. So here we go. So I'm going to change the y's just because I want to, because in the last problem I changed the x's, or the x's were the same. So in this case, I'm going to change the y's. And the easiest thing that you simply do here is all you're going to do is see how this is a 4 and how this is a 6. The only thing you need to do is multiply the top, okay, by 4 and the bottom line by 6. So notice all I'm going to simply do is that this is a 4, so I'm going to multiply this entire line by 4 and this entire line by 6. And all that simply is going to do is it's going to affect the y's in a way that I want them to, but, okay, that's all you have to do. And that will take care of our numbers weren't the same. It's now going to turn them to be the same. So all you have to do is if you want the y's to be the same, and they're not currently the same, you take the current y that's in the second line and multiply the first line. You take the one that's in the first line and you multiply the entire second line. So to show this very quickly, to show these conversions, okay, I am simply going to take the first line and I'm going to multiply it by this 4. So here we go. We take 4 times 2x minus 6y, close my parenthesis, equals what I multiply one side by, I must multiply the other side by, so this becomes 4 times 16. So 4 times 2x is now 8x, and then negative 6y is negative 24y equals 4 times 16, and this is what you may need a calculator doing this method just so you know. So 4 times 16 is 64. Okay, so then we move on to the next one. So here, this one is done. So there's equation 1. I'm going to take this over here and say, okay, this is now 8x minus 24y is equivalent to 64. First one's converted. Now I'm going to take the second one. And the second one, I'm going to multiply by 6, right? So I'm taking these two numbers and I'm just going like this, boom. And then I'm taking this one and going boom, right? So I hope that makes sense there. Quick way of doing it. So here we go. So I take that second line, and here it goes. So I go 6, okay, times, so 7x plus 4y, close the parenthesis, equals 6 times negative 19. So 6 times 7 is 42, so 6 times 7 is 42x, so I'm converting this to 42x, plus 6 times 4 is good old 24y, all right, equals, and then 6 times that 19, all right, is 114, but negative. So this is negative 114. So now I'm going to take that problem, and I'm going to throw it up there as well. So here we go. I get 42x plus 24y is now equivalent to negative 114. So from here, I now have that my y's, okay, are the same. Okay, again, I don't care about sign, just care that I have a 24 and a 24. So from here, they're now converted. You don't have to do all that stuff with LCM that your teacher probably sharing with you, and I even shared with my students. So if that ever happens, just multiply the other equation by the current coefficient, and you will get numbers that work. And yeah, so anyhow, your teacher may have told you turn these in the LCM, and the LCM of 6 and 4 is actually 12. But for the elimination method, you don't need to have to use the LCM. You just need a common multiple, to be honest with you. The reason we use LCM is because it just makes your numbers a lot smaller, and we're hoping that you know, if you're doing this by hand or without a calculator or whatever, that you're not going to make the mistake. So anyhow, back to this final step, what I do is I simply combine them. So here we go. How do I combine them? I look at the y's. I have a negative and a positive, which means I must add. So I'm going to put a plus, and a plus in between everything here. 8 plus 42 is 50x. Don't forget your variable. All right, so we're adding vertically here. These two cross out to 0. All right, and I get equals. So 64 plus negative 114 is good old negative 50. So now that I have negative 50, I go divide by 50, and I get x is equivalent to negative 1. Once I have x is negative 1, I go back to original problem, and the original problem, I'm going to substitute into there the x. So again, I'm just going to choose that first one. So this is now 2 times x minus 6 times y equals 16. Throwing that x in there, I get 2 times negative 1 minus 6 times y equals 16. All right, and 2 times negative 1 is negative 2 minus 6 times y equals 16. I'm going to go ahead and I'm going to do the addition of opposites, so plus 2 to both sides, just solving this out. And I get negative 6 times y is equivalent to 18. Last step here is divide by negative 6, and I get y equals negative 3. And just to point this out one last time, what you were solving for is an intersection point. So this is the coordinate pair of negative 1 comma negative 3. That is where these two lines intersect. So I hope I went through this as quick as I possibly could as a quick little rundown. If you liked the video, give it a thumbs up. If you have requests or questions, post them in the comment link. So as always, thank you for watching and have a good day.